Boundedness Theorem. I'll give you a chance to read the definition and the rules here. Okay, we have A here, and next we have the second one, which is B here. Okay, so I want you to look at keywords here. So if you have C less than 0, then you're going to see an alternate in signs. So that's a 0 can be considered positive or negative, but you can mostly see plus minus, or minus plus minus plus. So it should be alternating in signs. And with that, you will get no 0 less than the given C. Okay, so let's go back to our A here. The keyword here would be C greater than 0. So that would be the positive value for your C. So remember, your C here is similar to your X minus K from the previous formula we've shared to you using synthetic division. So K here is just same as our C here. So if C greater than 0, and then you can see the answers when you do synthetic division are positive, non-negative, then our f of x has no 0 greater than C. So again, no 0 greater than given value C. Okay, so let's have an example. Let's take the f of x. We've shown you the previous presentation. So you've seen this because we've shown this to you in a graph. X cubed minus 2x squared minus x plus 1. And our formula here is x minus c. So again, x minus c, and our c given here would be equal to 3. So we said that earlier that x minus c is the same as x minus k. So your c here is about the same value as your k here. So when you do synthetic division and apply the boundedness theorem, you will have 3 on the box here. And then let's copy the numbers beside the terms here. So those are the coefficients, which is 1 for x cubed, negative 2 for x squared, for x it's negative 1, and then 1. Again, this should be in descending order. If there's a missing term, you put a 0 in that missing term. Okay, let's break down 1 here, and then multiply to 3. It gives you a 3. We add this to get a 1 here, and multiply again to our c or our k here, which is 3. So that should be 3 times 1, that would be 3. Adding this again, it gives you a 2. Multiply again, it gives you a 6. Adding this, it gives you 7. Now, we are only after with the sign. So we have a plus sign here, a plus sign here, a plus, and a plus sign. So we can make a conclusion. So all positive signs. So as you can see, that's all positive signs. So therefore, the f of x has no zero greater than 3. Okay, so that's our conclusion. And that's from the boundedness theorem. Said that if c greater than 0, so our c here is 3, and all numbers in the bottom row of the synthetic division, so the bottom row would be this one, are positives or non-negatives, then f of x has no 0 greater than c. So it has no 0 greater than 3. So we learned from the previous presentation that the 0 here is less than 3. So there's no other zeros beyond that value 3. But we will show you again the graph for this f of x. So we will double check our answers here if this is true or not. Okay, so let's try. When the value now is c would be equal to 2. Okay, we know in the previous presentation that between 2 and 3 there is a 0 in between them. So our expected value now here, the answers would have different signs, or it will not be all positives sign. So we can try uh, the value 2 now. So again, our expected signs will not be all positives. Okay, so we're after on the signs only. So we didn't care about the value of the results. We're only after with the signs. Okay, so let's test this from the boundedness theorem. So this is letter A that we're trying to apply here. And then we bring down 1 here. 1 times 2, that would be 2. And then adding this, it gives you a 0. Multiplying 0 times 2, which is our c here, that would be a 0. Adding this would be a negative 1. Multiply again, it gives us a negative 2. Okay. And then adding this, it gives us a negative 1. So I'm going to look at the signs here. We have plus, 0 can be positive or negative. So we can put plus here, negative, negative. So as you can see, uh, the signs here changes and it's not all positives. So therefore, this is not all positive sign. So therefore, it has a 0 greater than our C, which is 2. Okay. Now, as you can see there, again, let me repeat that when you when we're going to graph this, you can see that there is a 0 in between 2 and 3. Okay, but there's no 0 beyond the value 3. Okay, so let's check our answer. So this is applying the boundedness theorem. So we can actually check that from the graph here. Okay, so now looking at the graph, we mentioned about C is 2 is over here and C is 3 over here. So the first calculation we did from the boundedness theorem, when we put C is equal to 3, there's no zeros beyond that value. As you can see, as I move to the right, there's no more zeros there. The zeros we have here is in between 2 and 3. So here's the next value for C, which is 2. When we test using boundedness theorem, then the signs are not all positives. So it means there is a 0 beyond this value, greater than 2. So there is a 0 from the graph here. Okay, so that's how we apply the boundedness theorem. So 3, when we apply 3, there's no zeros because the signs would be all positives. After doing the synthetic division, the result are all positive. When C is equal to 2, the signs for the result are not all positive since there is a 0 beyond 2. Okay, so we're trying to check now the negative 0 here. So we're trying to assume that C is negative 1 and probably C is negative 1/2. So to show you if there is a 0 in between them. Okay, but beyond that value, negative 1 also, as you can see, there's no 0 to the left here. Okay, from negative 1. So, but we have 1 here. So this is the negative 0 for this f of x. Okay, so we're going to write the f of x again. That's the x cubed minus 2x squared minus x plus 1. And we're going to assume a c here, a c which is negative 1. So negative 1 should be placed here in the box. And then the numbers beside the terms would be 1, negative 2, negative 1, and 1. And then we bring down 1. So 1 times negative 1 is negative 1. Adding this, it's a negative 3. Multiplying negative 3 times negative 1, that would be a 3. Place it here. Adding this, it gives you a positive 2. Multiplying 2 times negative 1, it's a negative 2. Adding this, it gives you a negative 1. So let's look at the signs. Sign here is positive, then we have a negative, positive again, and we have a negative. So you can see the signs, it alternates. So we have an alternating sign here, plus minus, alternate signs. So therefore, it has no zero greater than, or not greater than, it should be less than, right? Less than, because we're looking at the left side of the x-axis of the graph, so that should be less than negative. Okay, so we've shown you the graph a while ago. So that's going to the left, there's no zero there. So less than -1, there's no zero if it has alternating sign. And I will read letter B for the boundedness theorem. It says here, if C less than 0 and the numbers in the bottom row of the synthetic division alternate in sign. So this is the one that we're looking at. Then f of x has no zero less than C. So our C is -1, so it should be less than negative. Okay, so next we will show you if we assume C is equal to -1/2. And we know from the graph that there is uh, 0 in between -1 and -1/2. So let's try that -1/2 in the small box here. Then let's copy 1, -2, -1. These are the coefficients of the f of x. So long horizontal line, we bring down 1 here, 1 times -1/2, that would be -1/2. And then adding this, it gives us a -2 and 1/2. Or in a mixed number, or that's a mixed number form, or in improper form, you multiply -2 times 2, then add 1, that would be -5/2. Okay, we multiply -5/2 times -1/2. It gives us 5. It's a positive. Because a negative times a negative is a positive. 5/4. Just multiply the numerators and the denominators. So that's 5/4. Adding this, it gives you 1/4. Okay? Then multiply that again, it gives you a -1/8. Adding this, it gives you a positive 7/8. Now let's look at the sign. So we have a plus here, a negative here, a plus here, and then a plus here. So not alternating sign. So not alternate in signs, because that's plus minus plus plus. So therefore, we can make a conclusion that f of x, it has a 0 less than -1/2. Okay, so we know from the graph that there is a 0 in between -1 and -1/2. So the boundedness actually is true for these 4 cases that we're trying to show you. Okay, so note the values here. So I can show you the graph again. We have a -1 and a -1/2, and we have this f of x. So let's actually show you the graph again. Okay, so here's the graph. So as you can see here, here's the zero. That's um, in between -1 and 1/2. So you can see -1 is here, and then um, -1/2 is somewhere there. So let's zoom in so you can see clearly. So -1/2 is here, and there's -1 here. So when we tested -1, we have alternating signs for the result of the synthetic division, because as you can see on the left, less value for -1, there's no zero beyond that. When we tested -1/2, there's no alternating signs. For -1, it's alternating the signs there because there's no zero less than -1 according to the boundedness theorem. So that's why it alternates in signs. But here, when we plug in -1/2, there is a zero. So the outcome, the result, it's not alternating in signs. And that's how we apply the boundedness theorem. Again, those are two rules there for boundedness theorem, A and B.